trajectory planning lah. Trajectory is based on time. We going to calculate to control our robotic arm or manipulate. Robot manipulation is smooth motion lah. Is smooth motion. So what we control using a trajectory planning, based on the position that the robot going to move. So we try to control the velocity and the acceleration for each degree of freedom of robot arm. So that means every joint we can control. So if we have 2 joint, we have 3 joint of the robot arm, we can control the velocity and acceleration. So trajectory planning, the meaning is planning of robot trajectory from one location to another location in controlled manner. That means smooth lah. The example of manipulating packaging of egg, the industry. So how we manipulate the robot so that the egg is safe, because the egg is we call fragile. So we need to control the robotic arms so that the robot can move in smooth motion. So that we use a trajectory planning scheme. Okay, trajectory planning system. Okay, this is motion control, is a controller. So we have a robot arm. This is robot arm. So we have a feedback from encoder to inform the position, velocity, and acceleration of the actuator. So the important thing for trajectory planning is to ensure that the robot arm move in smooth and continuous motion. Okay, so there are 2 types of joint space scheme and Cartesian space scheme in trajectory planning. Okay. Okay, because I'm going to focus on the calculation. So this one is just a definition. Okay, joint space scheme, trajectory of each joint. That means every joint of robotic arm is specified in terms of joint angle by inverse kinematic. Smooth function is planned for motion from initial to final angle for each joint. Smooth function is that means smooth motion. Smooth motion is planned for motion from initial to final angle. So what we did for trajectory planning is we calculate the motion of robotic arm from initial to final angle for each joint. So that means every motion of your joint, so you will calculate your motion. So your motion, that means from position 1A to B, that means your robotic arm move from A to B. So you will calculate the velocity, you will calculate the acceleration. The time required for each joint is the same. So time required. So we move based on time. So what is the speed or the time you plan your robotic arm move? Maybe you move from A to B in 3 seconds. So in 3 seconds, so based on that time and the angle of your motion, so you will calculate, you can control the velocity and acceleration. Okay, now we go to the calculation. Okay. consider one joint of to move from theta 0 to theta final. For example, here we have one robotic arm. You want to move from A to B, for example, here from theta 0 to theta final. So this is position, theta 0. Maybe you want to move from 10 degree to 90 degree. So you want to move your robotic arm 10 degree to 90 degree. So what is the duration that you want to move? So you want to move from T0 to T final, maybe 0 to 3 seconds. So you want to move in 3 seconds. So this is the standard equation for position in cubic polynomial. So T is time. T is time. So that means it's time 0 here, for example. So at time 0, so everything is T is 0. 0 times 0, this is T equal to 0, T 0, T 0. So all this become 0, 0, 0. So at T0 equal to A0. A0 equal to theta 0. So that means if your position is start your arm at 10 degree, so A0 equal to 10. So we're going to define all this A0 until A3. So we're going to define all this value by using this equation. So if you want to find velocity, so you need to differentiate the main equation here, the position, based on time. That means theta is your robotic arm motion, your joint motion. Theta is joint motion. Rotation, joint rotation. So if you differentiate once over time, so you will get velocity. That means theta over time, theta per second means that it is velocity. Same like distance. Distance per second is velocity per second. So you differentiate one of this main equation. So theta A0 can be cancelled. So A1 change to be A1. So T power of 2 become 2A2 multiplied by T. T power of 3. So 3 put in the front. So 3A3 T power of 2. Because 3 minus 1. So you get velocity equation. And then if you differentiate again the second time over time of over second or over, normally we time is in second, so we differentiate again with time, so we indicate as double dot. So double dot mean acceleration. So if you differentiate again over time, so A1 can be cancelled, so T become T1 minus 1 is 0. 0, T power of 0 is 1. So 2A2. So 2 put in the front, multiply with 3 is 6. So 2 minus 1 is 1. So 6A3 multiplied by T. So this equation for acceleration. So you know the position of your motion of your joint. So you know your velocity, your motion of your joint from initial to final. You know your acceleration of your joint from initial to final. So from here you can define, you need to define the variable here, A0 to A3. How we get this variable? Okay, from this equation, so this is basic value or initial value we can define from this equation by assuming, for example, here at T0, For example, at T0 means that this is theta. Theta means position equation. Position equation. So at theta 0, okay, time 0, sorry, theta at time 0. So time 0 is here. Time final is here. Time final maybe 3 seconds, maybe 5 seconds, 4 seconds. Depend to the value. This is variable. So at time 0, so theta equal to theta 0. Theta final equal to theta at theta at time final equal to theta final. Theta at time 0 equal to theta 0. Theta at time final equal to theta final. So this is the angle, the position of robotic arm. Position of joint. And then from the velocities, we know that velocity of your motion of your robotic arm. So at theta 0 means that, at theta 0, at time 0, this means that your velocity of your arm at time 0 equal to 0 because you didn't move yet. You didn't move. When you didn't move your robotic arm, your joint, so velocity is 0. So this is fact. When you didn't move, that means your velocity is 0. And then when your robotic arm at your final position, so velocity at final time final means that your velocity is 0 because you not move also. So starting you not move, so velocity to 0, and final your robotic arm did not move, so your velocity also equal to 0. Okay. So this, when you replace t equal to 0, as I said before, when you replace t equal to 0, so everything is 0 except a0. So at theta times 0 equal to a0. Equal to 0. Actually, this one a0 equal to, equal to theta 0. Theta 0 maybe 0 degree, maybe 10 degree, maybe 20 degree, because this is variable. So a0 equal to theta 0. Theta final, position at theta final, so it's equal to this because it depends to time. So maybe your time is 1, so replace 1, 1, 1. So your t equal to 1. So theta final equal to the main equation. And then this is based on your velocity equation. So velocity equation. So at time, velocity equation at time 0. So this one all is 0. So T0, T0. So velocity at time 0 equal to A1. So you get A1 equal to 0 because velocity is 0. And then for final also your velocity is 0. Okay. Oh, sorry. Based on this equation and this information, velocity at initial or starting and final equal to 0. So this is velocity equal to 0 is T0. And then theta final, your velocity also 0. So it's 0. So you left the equation here. But the result is velocity equal to 0. Although you have all the equation, but your velocity is 0. The 4 equation is unknown and all variable could be solved. Okay. Then we can use elimination technique on these 4 equation. So we can use elimination technique to define A2 and A3. Because A1 you have already. A1 is 0. A0 equal to theta 1. This one is depend on your robotic arm initial value, angular value. Okay, to find A2 and A3, you can replace A1 into this, A0 into here, or you can use elimination technique to find A2 and A3. But in this note, they already solved the elimination technique, so you can use this simpler formula lah to find A0, A1, A2, and A3. So A0 is your starting or initial position. So theta final is your final position of your robotic arm. Theta 0 is your starting position or initial position. Time final is your duration of your arm move. How many seconds your arm you want your robotic arm move. This also same time final. But to find A3, time power of 3. To find A2, T power of 2. Okay, but here you have minus. A3 you have minus. This example. So by using this, okay, example exercise. I have 3 example here. So I show one and then another 2. You can try it by yourself. Make sure you get the same graph. So a single link robot with a rotary joint is motionless. Okay. So you see motionless. Motionless mean initial or starting starting position. Okay kah? Saya punya suara okay kah?
Okay, okay.
Okay. Motionless. So theta equal to 15 degree. So motionless mean initial 15 degree and is desire to move the joint in a smooth manner to 75 degree in 3 seconds. Something like this. I will show this. I also give this handout to you actually. But I'm going to show the figure. Okay. Okay, something like this. So you want to move from initial to final position. So for example, you want to move your arm, robotic arm. This is one joint. One joint robotic arm. So only one joint. So you want to move from 15 degree to 75 degree in 3 seconds. Find the coefficient of cubic that accomplish this motion and bring the manipulator to rest at the goal. Okay, nak gerakkan So nak gerakkan daripada point initial to goal or final. So how we define this? So how we need to find the coefficient of variable here, A0, A1, A2, A3. So we use the formula that they already simplify. So A0 equal to theta 0. Theta 0 here is 15. So theta A0 equal to theta 0. So A0 is 15 degree. A1 equal to 0. Because equal to velocity, we use this equation velocity. So we know that A1 equal to 0. And then we use this formula to find A2. So theta final is 75 minus 15. So 3 over 9, 9 is 3 power of 2 is 9 equal to 20. And A3 equal to negative 2 over T power of 3. So 2 power divided by 27. So and then theta final 75 minus 15. So you get coefficient is negative 4.44. So this value you need to put back into the equation. This is joint position or position. This is joint velocity or velocity equation. And this is your acceleration equation. But in examination or in test or what, so whatever, so you must show your value. You must show your value after you calculate here. For example, from point A to point B, or initial to final, I recommend that you don't just put 3 points. So you need to put at least 5. If you put 5, then you can see, you can plot a curve. If you only choose a 3 point here, you divide time equal to 3, just 3 scale. So you only can see a triangle shape, triangle curve. So you cannot properly define your curve. So for me, I recommend you to, when you do a calculation, make sure you divide more than 3. Maybe 4, maybe 5 of scale. So make sure you scale your time more than 3. So we can plot the graph. You can see a good plotting lah. For example here, so if you divide your scale equal to 6, that means your scale between 0 to 3 is 0.5, 1, 1.5, 2, 2.5. This is good lah. So how to find your theta here, your position, your theta? So by putting your t equal to 0.5. So this t change to 0.5 at theta equal to 0.5. This t equal to 0.5. This t equal to 0.5. So you get t 0.5 equal to value here. Theta value maybe 20. And then you replace t equal to 1. So this is 1 and this is 1. So you will get a theta value. And then you replace t equal to 1.5, 1.5, 1.5. So you will get a theta value here. So show your value of theta and your time. Then you plot. So make sure you show your step how to answer, because your step is higher mark than your final answer. So make sure you show your step as detailed as possible. So you will get a good mark. For velocity, so velocity same. So if you divide by 6 scale, so this one also you divide by 6. So your replace your time 0.5, 1, 1.5. So and then you get your velocity value. So at time 0.5, what is your velocity value? Angle velocity. This is theta per second is angle velocity. Angular velocity. So and then you put time equal to 1, you get your angular velocity. Then we plot lah. Then you plot. Same goes to acceleration. So at time 0.5, 1, 1.52. So you just replace here. So you will get a acceleration value. At time 0.5, what is your acceleration value? So acceleration is angular over time second square, time square. Because you differentiate twice over time. So you got time square acceleration. So what do you put in your controller, robot controller? This equation. So you put this equation into your robot controller. So when you put this equation into your robot controller, how you control your robot arm? So you control your robot arm. So based on this value, for example, at position, because your value will be, for example, position, your value will be feedback from your encoder. So you will get feedback from your encoder. So you know that where is your robotic arm position, theta, what is the value of theta. When you change your value of theta, so you will control your velocity and you also will control your acceleration. And then from this position, this equation, so you know your position of your robotic arm and you know what is the velocity suppose your robotic arm move. And you also know what is the acceleration suppose your robotic arm accelerate. So you will get value at each of position here. Then so that's why if you use a trajectory planning, so your robot will move in a very smooth motion. So that you can manipulate a fragile object lah, fragile object, because you not stop your motion immediately, because by using trajectory you will stop, your velocity will be controlled, so you stop in a smooth stoppages lah. That means you will stop in a smooth manner, so you not drastically stop lah. So this is the function of trajectory planning. Because you see the curve of your velocity, so your means that your robotic arm is not stopped immediately, because it's stopped by what we call in a smooth manner. So it stops little bit, what we call their velocity will be reduced little bit until the robotic arm stop. This one using a MATLAB lah. But yours one, you just calculate and plot a graph for position, plot a graph for velocity, and plot a graph for acceleration. But this is a motion without viewpoint. So we have 20 minutes. So I explain a motion with viewpoint. Before that, I'm going to ask you all, if you have this type of question, something like this, can you answer the question or not? So this one. So the question said that a single link manipulator, single link that's mean robotic arm manipulator with revert joint. Revert joint is a joint stopping at 15 degree, and it's desired to move in smooth manner to 75 degree in 3 seconds. So the question is almost like that. Just play around with the word. So the important thing is you know the starting angle, final angle, and what is the duration of motion. When you get these three value, then you can calculate this all.
Doctor, how is A10?
A10. A10. Okay, so we go back to the equation here. Okay, A10, because we get A1. So first we need to find A0. So first we want to get A0 by using position equation. This is position. Theta dot is velocity. Theta double dot is acceleration. So from the raw equation here, we can define already A0 equal to theta 0, A1 equal to 0. So how we get A1 equal to 0? Okay, I show you. Okay, based on the equation position, at t equal to 0, that's mean from this graph, okay, at t equal to 0, we know that the position is 15 degree. Okay. So that's the answer for that. So theta A0 equal to theta 0. When you put t equal to 0, all this 0, so you get that theta at time 0 equal to A0. What is the value of theta? The value of theta is 15 degree. So theta 0 equal to 15. And then how you know A1 equal to 0? Okay, from equation velocity, we know that at starting position, velocity equal to 0. Starting position equal to 0 because he's not moving. And then at the final position, your robotic arm go to final position and stop. So when your robot stop, you don't have velocity. So you have two position, both are 0. Both are 0. But which one you can get a value of A1 at starting point? At starting point, at theta velocity equal to time 0. So time equal to 0. This is 0 and this is 0. So velocity at time 0 equal to A1. What is the value of velocity at that time? Velocity equal to 0. So you get how you get A1. A1 because you get from velocity equation. So velocity equation, you have two conditions. At starting point, velocity equal to 0. At final point also, velocity equal to 0. So you can get value of A1 using at starting point. Starting point means that at theta equal T0 equal to A1. The rest cancel because time equal to 0. Why didn't take the final position? Final position T equal to 3. So 3. So this is 3. This is 3. So you cannot solve the equation. You cannot find A1. If you replace T equal to 3, so this is 3. So 2A23 multiplied by 3. You not solve it. You cannot solve. Tak boleh selesai. Tapi kalau awak ambil initial point, initial time equal to 0, you can cancel these two. You can cancel. So when you cancel these two, so you know that velocity at starting point or time 0 equal to A1. What is the value of velocity? Value of velocity at that time is 0. So now you get two parameter or two coefficient, A0 and A1 based on this main equation. And then how to define A2 and A3? So to define A2 and A3, you need to do cancellation technique. Cancellation technique. Or you can use a metric. What they call I forgot already the metric. But for me, I choose cancellation technique. You have three equation now, 1, 2, 3, and then you also have value already. A0, A1. So you can replace here. So A0, theta 0, in the equation is 15 degree. So this is 15. So you can replace here. And A1 you can replace equal to 0. You can replace here, A1. So A0 equal to 15 degree, A1 equal to 0. Then you already have value for A0 and A1. So you need to find A2 and A3. You can do a cancellation technique. But in this cubic polynomial, they already solved that issue. They put this equation to find A2. This is the equation. To find A3, this is the equation. So easier for you to find A2 and A3. Doesn't need to do a cancellation technique. Okay tak? A1 ni macam mana dapat? A1 ni berdasarkan equation velocity ni lah.
Alright,
Sebab,
doctor, thank you.
sebab velocity kita dah tahu dah. Starting kosong, tak ada velocity, dia berhenti kan. Final pun kosong. So, kalau awak make yang final, tak boleh selesai. Sebab final T dia 3. Example lah. So, sini pun ada 3. Sini pun ganti 3. So, you tak boleh dapat A2. Sebab equation tak boleh selesai. Sebab dia ada value. T ni ada value. 3 kali 2, 6. 6 A2. Ini jadi 3 kali 3 9. 9 A3. So, tak boleh selesai. So, awak nak cari value A1. So, awak ambil lah dekat initial position. Initial velocity. Initial velocity at theta time 0 adalah 0. Starting point 0. So, at time 0, sini akan jadi 0. Sini akan jadi 0. So, dua-dua ni cancel. Time 0, theta velocity at time 0 equal to A1. A1, we know that starting is 0. So, A1 equal to 0. So, kita dapat dua dah coefficient. Cuma nak cari A2 dan A3. A2, A3 pun dah ada. Theta final we have. Theta 0 we have. And then time we have 3 for example lah. Based on the equation lah. Based on question lah. Okay. Ini baru satu sendi . It's one joint only. If you have 2 joint and 3 joint, itu biar point pula lah. Okay. Ini senang je. Tak susah pun. Open book exam. So, awak dapat macam ni lah. So, A0 equal to 15 degree. Kan? So, sebab starting point 15 degree. So, A0 sama dengan 15 degree. A1 equal to 0 because your velocity at time 0 is 0. So, A1 equal to 0. And then A2, you replace this one, this value, so you get A2. A3, replace this value, you get A3. And then put all this coefficient value into main equation balik. So, ni yang position the equation, letak balik value. A1, A2, A3 tu. And letak balik dekat velocity punya equation, letak balik dekat acceleration. So, and then ganti je dah time tu. You divide your scale properly, but more than 3. I recommend that more than 3. Because if you put just 3, you can see it's a triangle graph. You cannot see curve. You only can see triangle graph. Okay. Then you replace with a suitable value of t here, and then plot your graph. Okay. But your level is a little bit higher. So normally the topic will will be asked is regarding cubic polynomial with via point. If the example here, if the desired velocity of the joint at the via point have non-zero value, then we can construct cubic polynomial as before with considering new constraint. So we adding a via point lah, a via point. Initial value theta 0, final value theta t final. Initial velocity at time 0, final velocity at time final. So this one we know that initial velocity should be 0 lah, should be 0. Applying the 4 constraint give 4 equation for the unknown. Okay, ini yang with via point dengan halangan, dengan obstacle. Okay, A0 equal to, okay, ini same as before. At theta 0 equal to A0. This one we get from the position equation. When you see dot, this is from velocity equation. Equal to A1, A1 equal to 0 lah. This one equal to A0, A0 equal to the angle of initial robotic arm. The angle of robotic arm, the initial position. Okay, at theta, this is position. Theta final, so this is the main equation lah. At time final, at time final, theta at time final. So you didn't know because theta final, because you have time. So when you have time value, so it's not 0. So it's not 0. So you just left the main equation here. And then velocity at time final. Velocity at time final. You also leave the equation here. Okay. Okay, to define A2 and A3 for cubic polynomial with via point, so you need to use this formula. Yeah, you need to use this formula. So A2, A3, yeah. So before this, you just use only this formula. But when you have a via point, so you need to minus 1 over time final. This is velocity, 2 theta velocity 0 time 0 plus theta time final velocity. This is velocity. And this is A3. So equation. So it's already simplified. So you just use this formula to find out A2 and A3. Okay, we see the example. Okay. So a bit complicated, but it's not difficult. With via point, that means that you need to calculate twice. Okay. Before this, you calculate between 0 to goal. This is goal, goal or final. 0 to goal or final position. But now you have via point in between. Via point in between 0 to goal, 0 to final, you have via point. So actually you need to calculate twice. That means you need to calculate between 0 to via point and then via point to final or to goal. So you just calculate twice lah. This we write like this because the above equation, the first equation, is between 0 to via point. This is 0 to via point. One equation, and equation 2, we put 2, 0, 2, 1, 2, 2, 2, 3. This is from via point to final. So via point to final. Angular constraint of first cubic. Okay. Initial position. For example, this is similar to without via point equation. So at theta 0 times 0 is equal to K10. This is similar. Okay, theta via point, because it's not theta final, but theta via point. So this is theta via point equation. Put back all the equation. Angular constraint for second cubic. And then this is from via point to goal. So via point. So we see here via point. Okay, A20. We take the equation number 2. So theta via point equal to A20. The time here cancel. So you left only A20. But A20, the position will be given. In the question will be given. So they said that theta via point equal to 15 degree. So A20 equal to 15 degree or 20 degree. So you just put here. And goal, this is goal. Theta, goal or final. You put back all the equation number 2. So this, you see that you calculate twice. You calculate twice. First from theta initial to via point, and then via point to final. Okay. Angular velocity. Okay, you see velocity. Start to rest. Sorry, start from rest. Start from rest is initial. Initial velocity equal to 0. From this equation. Okay. Differentiate once, so you get velocity kan. So you kena differentiate dulu. Differentiate once, you get velocity. Equation number 2 also differentiate, you get velocity. Then the same as before. So you cancel all time equal to 0. So you left A11 equal to 0. Okay, angular velocity constraint for second cubic and at rest. Okay, yang ni we left the question here. Both cubic must have the same angular velocity and acceleration at via point. Okay, this what the meaning of this? Both cubic must have angular velocity. That's mean velocity. Velocity and acceleration must be same at via point. Why he said like that? Because if you didn't use the same value, so your graph will not join. Will not join at this point. So at this point, your angle, your velocity, your acceleration must be same value. So your position also same value. Your velocity also same value. Your acceleration also same value. Then you can connect your curve. If you not use the same value, that means the final of this curve, initial to via to final. So at this point, position, velocity, and acceleration value must be similar. If you're not similar, then you cannot get a straight line. So awak akan terputus kat sini lah, mungkin sambung di tempat lain ni. So dia terputus. So make sure your value is similar value. Okay. This also has been simplified. So if you use this, you need to use elimination technique to find A10 to A13 and also A20 to A23. So you need to use elimination technique. But if you use this formula, so this is simplified formula to find A10 to A13 and A20 to A23. So you use the formula. When you get A10 until A13, so you replace into the main equation. You replace back into this equation, and then you do same as cubic polynomial without their point. Same as cubic polynomial without their point. Then you plot a graph. So that means you plot first half and second half. The second half must be connected to graph of the first half. So it's continuous lah. Continuous graph. It's not break here. Same go to velocity. So when you plot a graph, so your graph will stop here, first half, and then you continue another half. So that means if your robot have via point, so your robot will still can control your robotic arm motion from slower to faster and then from faster to slower in a smooth manner. So that means your velocity will increase at the middle, at the middle of traveling. So your robotic arm will be increase their velocity and then slowing down until at stop position, final position. So it's not become like higher velocity and then slower and then higher back and then slower. So it's not smooth. So when you use a cubic polynomial for trajectory, so you can control your robotic arm. Starting is slower and then go to faster as possible in the middle and then going back slowest velocity until your final position. So you can see that the curve is almost similar, but in different condition. Although in different condition, but your characteristic of your control will be the same. Velocity will be 0 at starting and 0 at final, and very high velocity at the middle position. And then your position, this is your angle, your position of your robotic arm. From 0 degree, maybe 10 degree to 90 degree position. And this is your velocity characteristic, and this is your acceleration characteristic. This is your point. So there are several ways to work out the desired velocity at your point. The user specifies the desired velocity at each via point in terms of Cartesian linear and angular velocity of the tool frame at that instant. Cartesian velocity at the via point are mapped to the desired joint velocity by using inverse Jacobian of the manipulator at that point. The system automatically choose Okay, the system automatically choose the velocity at the veer point, desired velocity at the point indicate with the tangent. The veer point are connected with straight line segment. If the slope of this line change, the sign at the veer point, choose zero velocity point A and point B. Okay, choose zero velocity at point A and point B. Point A, this is point B. Else, choose the average of two slope as the veer point. Something like this. If you have from zero, this is what? Zero to A to B. So we can control from this to here, zero to B. We can program the robot to control the velocity as smooth as possible lah, from 0 to B. So you have veer point here. So veer point. So how you control the velocity and acceleration to move from 0 to B? So by using a cubic polynomial trajectory. So that means your robot arm will control your velocity based on your angle. So when your robot move this angle, so this is your velocity and this is your acceleration. So you will get the value based on this equation. So that means your robot will move smoothly. Where's the equation? This equation. This equation to find out position, and then the other one to find velocity. You differentiate. So you need to differentiate. This is position. You differentiate one, you get velocity, and then you differentiate twice, you get acceleration. Then you put your value here. A10, A11, 12, 13, 20, 21, 22, 22, 23. Put inside your equation. Position, velocity, and acceleration. Okay, this example lah. This example is we consider TF equal to, normally you divide your graph into two lah. Into two. So it's your time that you going to from 0 initial to final is 4. So you divide by 2. So T1 equal to 2. TF1 2, TF2 equal to 2. So you can see more example inside the slide that I give here. This one. So this is without veer point. Example 1. So you get the answer here. So when you put the value, when you get this value, you put this value back into the equation position, velocity, and acceleration. Then you can calculate the angle, for example, here. So replace time into this t value. So you get angle. That's your position. And if you replace t value here, you will get velocity value, angular velocity. You replace t inside with acceleration, so you get acceleration over time. Acceleration value. This you see the exercise also have the same meaning, but they use a different wording. For example, initial angular position. Initial is starting at 10 degree and end at the final angular position. Okay. So 90 degree. So and then how long it take for move from initial to final. So suppose he gives the value here. Okay, calculate the trajectory for robot joint, scale the position profile. Okay, consider link robot manipulator, rotary joint, design a cubic trajectory, start from initial angular and end angular. Okay, he not give the time, but he write down here, starting from 0, initial, 0, this is time, 0 second, and final at 4 seconds. So you know that the arm move from 0 to 4. That means 4 seconds, within 4 seconds. So this is indirect given value, indirect. And this example, this is direct value. So he give a direct value, move from 30 degree to 150 in 5 seconds. So this is direct question. And this is cubic polynomial with via point. So this is via point. Similar to the note that I give to you, that I show you just now. So this is the main equation, this is velocity equation, this is acceleration equation. How you get this? By differentiate. You get. So similar to the without via point. So with via point is similar. Only that you need to calculate twice lah. Because you have half. You need to calculate twice because your robot must move from initial to via to final. So that's mean you need to calculate twice. So this is the equation that you need to use for trajectory with via point. This one is similar. This example equation question. So you can see this higher order polynomial is not in the examination. So I focus on cubic polynomial with via point only. Okay, see this? Starting initial 10 degree and then pass the via point at times 1 second. Time 1 second. Equal to 5 degree and then stop at the final angular position 50 degree. Okay. So 0 second, 1 second, 2 second. That's mean time 2 second. So robot move from 0 position from 10 degree and then go to 5 degree, then go to 15 degree in 2 seconds. In 2 seconds. Because this is 0, 1, 2. In 2 seconds. This one, start from 0. Via point is 2 at 2 seconds. Final at 4 seconds. So via point located at 2 seconds. Okay, that means 10 degree and then 50 degree and then 90 degree. In 4 seconds. So this is indirect question. 5. Okay. Similar to via point lah. Without via point and via point similar, but via point you need to calculate twice. That's all. Mungkin semua dah mengantuk dah. Okay. Okay, ini dah dah. Yang ni macam dengan awak punya lab lah. So lab 3 awak tu macam ni lah. So lab 3 awak tu, your lab 3, so you have 2 join, 2 link, 2 link and 2 join. So when you put the program that I give to you, and then your link length will be different because you will use your own metric number. So you need to define, not to define, to to ensure that your robotic arm located or manipulate inside this working envelope, something like that. So you must put the value so that your robotic arm located in manipulate inside the working envelope here. So you cannot go beyond this working envelope. So how to do that? You need to change some value inside your program, the program that I give. So you just play around with the value. So this one using MATLAB. So you can use. So your robotic arm will be something like this. Will look something like this inside your laboratory.
Nanti lab 3 pun kena pergi ke Makmal ke? Kau tak perlu?
Tak payah. Lab 3 boleh buat di rumah lah.
Alright.
Okay. Senang je lab 3 tu. You copy
Kalau
the
nak
program.
pergi lab,
Copy je program tu. Masuklah MATLAB je.
Rajin tidak.
MATLAB version lama pun boleh. Sebab dia bukan high spec program tu. Okay. Untuk trajectory ni kalau tak faham boleh tanya. Nanti waktu lab pun boleh tanya. So make sure awak boleh jawab lah trajectory ni senang. So it's very easy to calculate because all the value all the formula already given. You just plug in the value and plot a graph. Plot a graph. So your OBE one will be cover DH method and trajectory lah. DH method and trajectory. So we do a test exam on 1st July. Friday night. Next week. Friday night next week. Okay, untuk DH, okay, forgot to remind you. Do you want to see the mark?
Yes.
Tutup lagi nampak.
Mau.
Ya.
Ish, banyak apa bajet kan?
Ni bajet ni, grant. Nampak pula ada bajet tu. Okay. Question. Dengan silap buka soalan sudah. Ada soalan tu. Bahaya.
Buka page tau.
Okay, jadual perdana. Mid-sem. Mid-sem kena. Okay, PSDC. Ini saya tengok awak punya skema macam ni lah. Ya, kita tutup skema ni. Matric number. Kita nampak matric number. Kita nak Malik boleh nampak pula mana. Okey, ambil yang smaller to larger. Okey, nampak matric number ya. Okay, so this is your mark lah. Mana tengok ni. Boleh nampak tak? Ni awak punya skema ni. Okay, this one. Ini tutup lah nanti Amal pula yang kecewa. Lihat ni. Okay. Okay, nampak tak? Okey, yang rugi banyak dekat question A lah. Question A, draw working envelope. Working envelope tu a lot of student didn't draw working envelope. Working envelope ni yang gambar Cartesian, itulah working envelope tak? Mana contoh dia? Kinematik. Sekejap, saya nak tunjuk working envelope. Okay, kinematik. Nampak tu. Inilah working envelope. Yang ramai tak lukis tu. 2 markah. Bukan yang ni Yang ni bukan. Yang bawah ni. Ni working envelope. Kalau cekap lagi lukis yang macam ni. Mana ni? Ada yang tak, yang confuse lagi tak working envelope? Ni working envelope lah tadi tu kan. Ni working envelope ni. Awak tengok kalau macam articulated robot 3 rotation ni macam ni lah. Kalau yang 2 rotation 1 prismatic macam ni. Kalau 1 rotation 2 prismatic silinder. Kalau Cartesian semua prismatic, all prismatic Cartesian. Macam ni. So yang ni lah 2 markah tu. Ramai tak lukis, rugi Nampak dah ni? Tak mau tengok atau takut nak tengok apa? Ataupun saya nak sort. Larger to smaller.
Doktor, yang markahnya yang mana satu, doktor?
Okey, markah yang ni. Lupa pula nak beritahu. Ni markah dia ni.
Per 100 ke, doktor? Per
So,
100 ke?
per 100. Yang ni per 100. Sebenarnya per 10, 8.5 lah. Kalau yang ni lah per 10, 8.5 lah. Tu, lihat ni. 85, 85. 127. Ni apa ni? Nur apa ni? Nur in Amni. Oh, markah dia tinggi. Nur in Amni. Yang ni saya tunjuk lah markah tinggi kan. Beh Junho. 85. Saudi Wen 85. Muhammad Adib Hifzuddin 80. Rita Sri 80. Muhammad Farouk 78.
Ayah bagi tangan pun.
Ni hak tinggi-tinggi dia beritahu lah. Rendah-rendah tak beritahu. Ni hak tinggi-tinggi. Kok ada student nak rujuk kan. Nak study lah. Power ni. Student power.
Jangan rujuk saya terus. Tak boleh.
Muhammad Khalid bin Walid 78. Power ni. Boleh rujuk ni. Wan Muhammad Akli 78. Halal ni 75. Okay lah. Tengok ni ya. Okay. Tadi tu yang power lah. Markah tinggi. Yang penting jalan kira jangan tinggal. So jalan kira memang markah dia tinggi. Okay, nampak? Ini yang tak ada metrik nombor ni saya tak buat lagi sebab student ni baru masuk dalam sistem AMIS. Saya pilih nama. Bila saya nak marking, saya tengok ada 100 tu lah student. Sebelum tu ada 90 lebih. Nampak? Ini saya ikut markah tertinggi ke rendah lah. Lagi tarik-tarik, saya tertarik markah pula. Ni markah dia yang ni Dia pun yang bawah tu nampak nama pula. Nampak markah? Tinggal berapa orang ni? Kan tinggal 2 orang
Tak nampak doktor.
66. Oh, ramai. Tak.
Share lah doktor, file doktor.
Doktor,
Tak nampak lagi.
Doktor.
how many percentage keberatan to this midterm?
10 mark. 10 maksud dia kalau 45, 4.5 mark. Saat saya nak balik ke tadi 70 kan. Start pada sini lah. Okay. Kecil ke besar ni? Tulisan ni takut lagi kecil awak tak nampak pula.
Okey doktor, okey.
Okey lah. Okey. Okey.
Nak atas nanti.
Okey, tunggu bawah lagi Okey. Ya, DH method lebih kurang yang ni DH method lebih kurang yang ni. But this question for OBE is a bit easier lah. Because I already give robot in frame. So awak dah nampak dah lah. You can see the orientation of robot lah. So tak payah susah-susah yang nak ni imagine. So I already give the question in frame figure. Okay, tak lagi saya turun lagi. Ni sampai 50 ni lulus lagi. Relax lah. Awak punya assignment, quiz, lab semua tinggi-tinggi markah.
Doktor boleh minta answer scheme tak untuk yang midterm?
Yang ni
Answer scheme.
Answer scheme ni. Yang merah tu.
Yang dalam kerja punya.
Dalam kerja dia jenuh lah. Ni saya buat dalam ni. Dalam ni. Ini. Okey, jangan kejar dia. Ni. Saya tak turun bawah lagi. Saya tak pergi habis tu. Apa soalan ni should be inside your assignment lah. Ada student yang dapat tak soalan ni? Sebab dia ada lebih kurang 100 student. So mesti ada soalan ni dalam awak punya assignment. Cuma tak tahu siapa dia je. Nampak So skema dia. Skema. Tapi tak sama lah. Untuk yang test, yang final exam nanti lain. Yang OBE lain pula. Saya zoom start sikit. Ni skema dia. Screenshot skema dia. Untuk pengetahuan je lah. So yang ni awak nampak yang ni saya dah bagi dalam soalan. So Z1 pun, Z1, Y1, X1 pun saya dah bagi dalam soalan. Z3, Y3, X3 pun saya dah bagi dalam soalan. Cuma awak nak cari X2, Z2, Y2. Itu sajalah 2 markah tu. Tapi nak lukis dia tu kena lukis dia punya frame lah. Frame. Cuma nak cari Z2, Y2, X2. Macam ni linear dia mesti yang linear ni adalah Z lah. Yang linear ni adalah Z. Macam ni kan, vertical Z. Yang ni yang linear ni adalah Z. Okay, ni formula dia. Saya ambil formula ni, saya letak dalam ni. Saya dapatlah jawapannya. Setiap orang tak sama lah. Saya ikut nombor metrik awak ni. Awak lah teruk nak kira. Saya senang je kira. Saya tarik drag je. Dapat jawapan awak semua. Okay, ni jalan kira dia. Okay, jalan kira dia. Adalah step dia lagi daripada you nak multiply daripada 0 multiply 1, 1 multiply 2, 2 multiply 3 kan. Metrik tu. 0 to 1, 1 to 2, 2 to 3 ada lagi lah kat belakang tu. Tak tunjuk lah kat sini. So selepas multiply 0 to 3, inilah dia punya equation metrik dia. 4x4 metrik. After multiply 0 hingga 3 ni. Frame 0 to frame 1 ni. Frame 0 to frame 3 ni. After multiply. So ini dia punya metrik. So ada banyak juga yang dapat tepat. Ada yang 85 tu dia dapat tepat lah ni. Mungkin dia punya assignment soalan ni kot. So dia punya equation nampak sama. Ni dia tak share dengan kawan-kawan kot. Mungkin tak sempat sebab nak kira kan tak sempat. Okey.
Doktor bawah sikit doktor.
Jana?
Tak nampak lagi ni.
Tak nampak? Yang mana? Oh, tak tengok. Tak ada 85. Saya ulang balik 85. Tengok nombor metrik ni. Ni nombor metrik awak ni. Ni Muhammad. Yang tak tahu ni Muhammad Akli. Wan Muhammad Akli. Final exam lagi banyak lah markah dia. So OBE1 akan bawa 30 markah 30 markah. OBE2 30 markah. So make sure awak study lah yang DH ni dengan trajectory tu. Study mark sikit lah.
Doktor,
Ya.
midterm berapa markah?
Okay, midterm 10 markah.
Persen?
Ni kalau 75 ni 7.5 lah. 7.5. Ni 70, 7 lah. 7 markah.
Okey doktor.
Okay. Kawan nak saya susun ikut abjad ni. Ikut nombor. Kita tengok ni. Okay, 55. Yang bawah 40 tu memang dia jawab separuh je. Sebab tu dia dapat 20 lah semua tu. Kali ni jangan tinggal kosong. Kira juga matrik tu. Belajar balik 4x4 matrik macam mana nak kali. Ini 8 markah kat situ. Walaupun jawapan awak dapat tak betul, at least nampaklah jalan kira tu. So saya boleh bagi markah. Jawab dah betul dah. Dia ada 3 matrik dah. So ada frame A, frame B, frame C. Tapi tak kali matrik tu. Saya pun tak tahu siapa. So malam ni belajar praktis kali matrik lah. 4x4. Sebab jalan kira saya bagi markah banyak. So jalan kira saya bagi 8 markah. Final answer saya bagi 4 markah je. Kalau betul dapat 4 markah. Kalau salah, kalau jalan kira banyak, so awak dapat 8 markah. Oh banyak lagi tu. Jalan kira dari final answer. Marking. Nak kena tengok satu. Kiri kanan. Yang jawapan hampir-hampir tepat pun, markah tinggi juga. Ada siapa hantar komen apa ke? Soalan yang hampir sama lah. 3 join juga. Untuk yang DH, untuk OBE ni pun memang 3 join juga. 3 join ni pusing pi, pusing mai, sama je. So dia mesti sama ada 3 rotation, ataupun 1 rotation, 2 prismatic, atau 2 prismatic, 1 rotation. Pusing-pusing balik, sama je. Okay, nampak lama. Kadang setengah tu dia you answer because your imagination of angle is different, so you get a negative value. I still give a high mark lah. But your value is similar to this answer, only your imagination of your axis different, so you also get high mark. That's why I give a high mark on calculation step. Okay. Nanti prepare